Okay, this is our ME100 project, the automatic antenna alignment system. So we'll begin with a live demonstration. And in short, we're using the orientation data from this guy, an analog for a rocket, to point the antenna.
So we'll begin. So we can start with X direction control and as well as Y direction control. And both can move at the same time.
And then to show our telemetry system, I'll start a server. And then as Bruce moves it around, you can see that we are getting HTTP post requests. That is coming from the base station ESP32. And then after data collection period, it will then produce a graph. So in this case, we're using this is all on our Wi-Fi network. So all the machines are on the same network, but it's just using HTTP. So that could easily go throughout the entire internet. And so there you can see there's the angle over time. You can see that when it was flat when you picked it up, then there's some change for that amount of time, and then kind of went back flat at the end. So to explain a little bit more, Bruce will talk about what exactly this side is doing.
Yeah, so this side more represents our sensor system, where we have an IMU on board, which is giving us our orientation. And what that's doing is being transmitted directly to this guy and allowing us to control the entire system. On the mechanical side, what we have are two stepper motors. The bottom one provides us with 360 degrees parallel to the ground, while the one on the plate will provide us with 0 to 90 degrees from parallel to perpendicular to the ground. And this allows for full coverage of the entirety of the sky.
And so then there's another ESP32 down here. And again, these two ESP32s and the laptop are all on the same Wi-Fi network. And so we kind of just have them going between the different IP addresses to kind of request data from one another or post data to the server. So the base station ESP32 requests the orientation data from the IMU. And then once it gets that, it uses that to update the target positions and drive these two stepper motor controllers, which then can control the two stepper motors. We have a slip ring on the inside. You can kind of see it underneath here, that allows the wires to pass through. So this thing can rotate a full 360 degrees without the wires getting caught. And so then, and again, there's right now it's just set for 30 seconds of data logging, but it's just a simple server script, but it could be set up to do that periodically, or we actually have the capability for remote control. So you see from here, from the computer, I can type in which motor I want to turn, and then how much I want to turn it by, and then that one will move, and I can target the other one, and then it will move as well. So the connection to the internet allows us to do both logging of data, and then because you have that control capability as well, we could actually put this far away from the launch site and just use this remote telemetry and remote control in order to position it, or have the system position itself as a rocket flies through the air, which is the ultimate goal, to allow automatic tracking and having multiple of these base stations around the launch site that are all kind of being monitored from the central launch pad. But that way we don't have to have a person standing out at each one. We can kind of just use the kind of this IoT internet-based communication to manage all of them.
Thanks for listening.